Hello guys. So today in this video we are going to be looking at symmetric tree, and so this is the problem statement. You can go through it by pausing the video if you want. This is like pretty straightforward question. We just need to find out if the tree is mirror image of itself or not. So you can see the first one is symmetric, but the second one is not. So they want us to solve iteratively as well as recursively. So first of all, I would like to start with iterative solution, and I will be doing this using a queue. So I'll be doing this using breadth first search, which I find simpler. So from collections, I will import dq. Then so suppose if root is null, that means that it is an empty tree. That is, it is a symmetric, right? Like it is subset. So you can just think of it as a symmetric tree. So if not root, we will return true. Else we will start with a q view. So if just a root was there, it is symmetric anyway, right? Because since it has just a single node, we don't need to worry about anything else. So what I'll do is I'll start the queue with its left and right nodes instead of taking the root itself, because that will make sense. Like we will be starting from the child node of the root node itself. We don't need to worry about root node. So root dot left and root dot right. Now let's start with while q. I will pull out all those two nodes. So if I needed to explain how this algorithm would be working, so it would be like this. So we won't be considering 1, but we will be putting 2 and 3 first in the queue, right? We will be popping 2, then 3. We will check if 2 and 3 has the same values. If they have the same values, then we will continue for the next nodes. That is breadth first search. So we will be adding 4. But here is a point. Like if it was a mirror image, we won't compare the 4 with 5 or 6. We would be comparing this 4 with the right element of the 3. So what we will do, we will be adding like every node's left element, then second node's right element, and then similarly its right node is compared with this left node. So we will be adding its right node and then the node 2's left node. All right, then let's start. So node 1 node 2 equal to, we will keep pop the nodes present in the queue right now. Here you go. So now we get 2 nodes, right? Now if both of the nodes are null, that means we have reached like this part after the root node. That is anyway symmetric, so we will just continue. But suppose we reach at this node, right? It doesn't, at this node it has a left node, but it doesn't have a right node. Its right node should be compared with the 2's left node. Sorry about that. So it has 2 has 4, right? Just for simplicity, it is not a symmetric tree, but I'm trying to explain using this one only. So with 2, 4, you have a left subtree for 2, but for 3 we don't have a right subtree. That means we can conclude here only that it is not a mirror image. So how will we write that in the code? So we will do something like this: if not node 1 and not node 2. That means we still need to figure some other nodes. We can just continue, but if not node 1 or not node 2, that is either of them is null, we know that this is not a symmetric tree. We just return false. Now, as I mentioned earlier, we will be comparing the 2's left to the 3's right. So we have 2 and 3 in this queue. We popped it. This is node 1, this is node 2. So we will be putting node 2's left node first, node 1's left node first, and node 2's right node first. Similarly, then we will put node 1's right node and then node 2's left node. So if they have equals, they will be symmetric. So now we can keep else if here, because either one of them will be true. Then we have to check for node values. If that means after going through this code, we are sure that neither of them are null. So we can check for the values of node 1 and node 2. If node 1 val is not equal to node 2 dot val, we return false. Now, as I mentioned, we will be adding alternate root nodes to the queue. That is, let's see, queue dot append node 1's left, then we will append node 2's right, now we will append node 1's right and node 2's left. So this will conclude, like if our program returns from here, it will return false. If it is not, if the program doesn't return from here, we know that the tree is symmetric and we can return true. Let's see, true. Let's submit it. None type object, no hell. I'm just checking where did it go wrong. If node dot val not equal to node 2 dot val. Oh, just here I made a small mistake. If not node 1 or not node 2, we return false. Sorry about that. Made a small mistakes. Okay, this is done now. Thank you guys.